@NCERT video welcomes you. Today we are going to start Chapter 2 Lines and Angles. Let's start Chapter 2 Lines and Angles. In this chapter, we will explore some of the most basic ideas of geometry, including points, lines, rays, line segments, and angles. These ideas form the building blocks of plane geometry and will help us in understanding more advanced topics in geometry such as the construction and analysis of different shapes. 2.1 Point. Mark a dot on the paper with a sharp tip of a pencil. The sharper the tip, the thinner will be the dot. This tiny dot will give you an idea of a point. A point determines a precise location, but it has no length, breadth, or height. Some models for a point are given below. The tip of a compass here, the sharpened end of a pencil here, the pointed end of a needle here. If you mark 3 points on a piece of paper, you may be required to distinguish these 3 points. For this purpose, each of the 3 points may be denoted by a single capital letter such as Z, T, P. Z, P and T. These points are read as point Z, point P and point T. Of course, the dots represent precise locations and must be imagined to be invisibly thin. Okay, these dots are read as point Z, point P, point T. 2.2 Line segment. Fold a piece of paper and unfold it. Just fold it and then unfold it. You will get a crease like this joining A and B. Do you see a crease? This gives the idea of a line segment. It has two endpoints A and B. You can see endpoints A and B. Mark any 2 points A and B on a sheet of paper. Try to connect A to B by various routes as shown in figure 2.1. You can see A and B has been connected through various routes. What is the shortest route from A to B? This shortest path from point A to point B, including A and B, as shown here, is called the line segment from A to B. It is denoted by either AB bar or BA bar. The points A and B are called the endpoints of the line segment AB. 2.3 Line. Imagine that the line segment from A to B, that is AB bar, is extended beyond A in one direction and beyond B in the other direction without any end. See figure 2.2 like this. This is a model for a line. Do you think you can draw a complete picture of a line? No. Why? You can see it. If you extend, it will go beyond the paper. It will never end. So you can't draw a complete picture of a line. A line through 2 points A and B is written as AB with double-headed arrow over it. It extends forever in both directions. Sometimes a line is denoted by a letter like a small letter L or a small letter M. Observe that any 2 points determine a unique line that passes through both of them. For example, if you take points like X and Y, You can draw only a single line through them. 2.4 Ray. A ray is a portion of a line that starts at one point, called the starting point or initial point of the ray, and goes on endlessly in a direction. The following are some models for a ray. Beam of light from a lighthouse. Lighthouse is used to show direction to boats. Ray of light from a torch. Sun rays. You can see all three are starting or initial point from where the rays start and go endlessly. Look at the diagram figure 2.3 of a ray. 2 points are marked on it. One is the starting point A and the other is a point P on the path of the ray. You can see figure 2.3 given here. A is the starting point and P is on the ray. We then denote the ray by AP with single head arrow over it. Figure it out. 1. Rihan marked a point on a piece of paper. How many lines can he draw that pass through the point? If you draw a point on a piece of paper, there are infinite lines that can pass through it. You can't count the number of lines passing through it. Sheetal marked 2 points on a piece of paper. How many different lines can she draw that pass through both of the points? If you draw 2 points on a piece of paper like this, you can draw only one line passing through them. Can you help Rihan and Sheetal find their answers? I have already discussed. 2. Name the line segments in figure 2.4. Figure 2.4, you can see line segment LM, MP, PQ and QR. Which of the 5 marked points are on exactly one of the line segments? You can see point L and point R are exactly on only one line segment, which are on two of the line segments. You can see point M, point P, point Q are on two line segment. For example, point M is on line segment LM and MP. Point P is on line segment MP as well as on PQ, and point Q is on line segment PQ as well as QR. 3. Name the rays shown in figure 2.5. You can see figure 2.5. You can see ray TA. You can see ray TN. You can see ray TB. Is T the starting point of each of these rays? Yes. You can see rays are starting from point T. 4. Draw a rough figure and write levels appropriately to illustrate each of the following. A. OP with double-headed arrow, that means line OP, and line OQ meet at O, that means two lines that intersect at point O. OP and OQ. B. Ray XY and ray PQ intersect at point M. Ray XY and ray PQ intersect at M. X, Y and PQ. C. Line L contains point E and F but not point D. Line L contains point E and F but not D. D. Point P lies on AB. AB is a line and P lies on it. 5. In figure 2.6, name A 5 points. You can see points B, C, D, E and O. You can write B, C, D, E and O. B, a line. You can see a line. It has 4 points. That is D, E, O and B. You can write that line as line DE or line EO or OB, or you can write it as DB. Okay, you can write it as DB. You have to write only one of these. You can write this one. C, 4 rays. You can write any 4 rays. You can write OC. You can write OB. You can write ED. You can write OD. Okay. You can write any ray, but you have to mark single-headed arrow over them. OC, OB, OD, ED. D, 5 line segments. You have to write 5 line segments. That means you can write any line segment between 2 points. You can write DE. You can write EO. You can write OC. You can write OB. You can write OD. 6. Here is a ray OA, figure 2.7. It starts at O and passes through the point A. It also passes through the point B. A. Can you also name it as OB with single-headed arrow, that is ray OB? Why? Figure 2.7, you know A ray starts from a fixed point and goes endlessly in one direction. So you can name that ray with any other point on that ray. For example, you can name this ray as OA with single-headed arrow or OB with single-headed arrow. Both represent the same ray. B. Can we write ray OA as ray AO? Why or why not? You already know that ray OA means O is fixed as shown in figure. But ray AO means A is fixed and ray starts from it. But in figure you can see both are not the same. So this is wrong. So the answer is ray OA cannot be written as ray AO. 2.5 Angle. An angle is formed by two rays having a common starting point. Here is an angle formed by rays BD and BE, where B is the common starting point. Figure 2.8. You can see a common starting point of two rays, that is ray BE and BD. So an angle is formed between the two rays with a fixed point in common. The point B is called the vertex of the angle, and the rays BD and BE are called the arms of the angle. You can see point B is written as vertex and ray BD as arm and BE as arm. That is, BD and BE are arms of the angle. How can we name this angle? We can simply use the vertex and say that it is the angle B. To be clearer, we use a point on each of the arms together with the vertex to name the angle. In this case, we name the angle as angle DBE or angle EBD. You can see angle DBE or angle EBD. Okay, kindly note the naming of angle. This is angle DBE, or this can be also written as angle EBD. The word angle can be replaced by the symbol of this angle, that is angle DBE or angle EBD. Note that in specifying the angle, the vertex is always written as the middle letter. You can see B, the vertex is already written in the middle. To indicate an angle, we use a small curve at the vertex. Refer to figure 2.9. Like this. Vidya has just opened her book. Let us observe her opening the cover of the book in different scenarios. You can see case 1, case 2, case 3, case 4, case 5, case 6. In first case, the book is slightly opened. In second case, the book is opened more. In third case, you can see a straight opening. In fourth case, the book is inverted more and more. in fifth and sixth case. If you notice the angles there, then here smaller angle, then here larger than that, here larger than that, then again larger than that, then again larger, and then completely inverted like this. Do you see angles being made in each of these cases? Can you mark their arms and vertex? Yes, this corner is the vertex and the cover is the arm. Which angle is greater? The angle in case 1 or the angle in case 2? You can see angle in case 2 is greater. Just as we talk about the size of a line based on its length, we also talk about the size of an angle based on its amount of rotation. So, the angle in case 2 is greater, as in this case, C needs to rotate the cover more. Similarly, the angle in case 3 is even larger than that of case 2 because there is even more rotation, and cases 4, 5 and 6 are successively larger angles with more and more rotation. Figure 2.9. The size of an angle is the amount of rotation or turn that is needed about the vertex to move the first ray to the second ray. Here vertex, here you can see initial position of ray, here final position of ray. Amount of turn is the size of the angle. Let's look at some other examples where angles arise in real life by rotation or turn. In a compass or divider, we turn the arms to form an angle. If you take an angle like this, then you have to fix this point of the compass or divider here to make an angle like this. The vertex is the point where the two arms are joined. Identify the arms and vertex of the angle. These two are arms of the angle and this is vertex of the angle. A pair of scissors has two blades. When we open them or turn them or cut something, the blades form an angle. Identify the arms and the vertex of the angle. Okay, in this figure, if you see this compass or divider, you can see an angle being formed here and these two are arms. Similarly, in this scissor, you can see these two blades are arms and this is angle. Look at the pictures of spectacles, wallet and other common objects. Identify the angles in them by marking out their arms and vertices. You can see arms, vertex, this one, and angle. Similarly, arms, vertex, and angle. Similarly, in this picture, similarly in this picture, similarly here, and similarly here. Do you see how these angles are formed by turning one arm with respect to the other? Teacher's note. Teacher needs to organize various activities with the students to recognize the size of an angle as a measure of rotation. Figure it out. 1. Can you find the angles in the given picture? Draw the rays forming any one of the angles and name the vertex of the angle. You can see two pictures are given here. In first picture, you can see points A, B, C and D. So the angles could be angle A, D, B, that is this one, and angle B, D, C, that is this one. And another angle is there, that is angle ADC, that is the bigger one. Similarly, for the second picture, you can first mark the points and name the angles, vertices and arms. For example, you can mark these points as A, B, C and D. You can name these points as X and here Y. So the angles here are angle AXB, angle BXC, angle CYD and angle DYA. Kindly note that. Similarly, you can mark points like A, B, C here and X, Y, Z here. The angles could be angle A, B, C, angle X, Y, Z. Similarly, for this picture, you can name the points and mark the angles. 2. Draw and level an angle with arms ST and SR. Since S is common in both line segments, so the vertex will be at S. ST and SR. 3. Explain why angle APC cannot be labeled as angle P. If you observe this picture carefully, you can see this angle, and the bigger one, that is this one. If I name these angles, then the angle will become angle APB, angle BPC and angle ABC. Angle APB, angle BPC, angle APC. Since P is in all three angles, you can't name this angle as angle P. This is wrong. 4. Name the angles marked in the given figure. If you observe this picture carefully, you can see angle RTQ, then angle QTP, and the bigger one, angle RTP. So the angles are angle RTQ, angle QTP, and angle RTP. 5. Mark any 3 points on your paper that are not on one line. Label them A, B, C. Draw all possible lines going through pairs of these points. How many lines do you get? Name them. How many angles can you name using ABC? Write them down. and mark each of them with a curve as in figure 2.9. You can try doing this. 6. Now mark any 4 points on your paper so that no 3 of them are on one line. Label them A, B, C, D. Draw all possible lines going through pairs of these points. How many lines do you get? Name them. How many angles can you name using A, B, C, D? Write them all down and mark each of them with a curve as in figure 2.9. 2.6 Comparing angles. Look at these animals opening their mouths. Do you see any angles here? If yes, mark the arms and vertex of each one. Some mouths are open wider than others. The more the turning of the jaws, the larger the angle. Can you arrange the angles in this picture from smallest to largest? You can see this angle is smallest. This one is larger than that. This one is larger than that. So the largest one will be this one. That is that of the baby bird. Is it always easy to compare two angles? Here are some angles. Label each of the angles. How will you compare them? Draw a few more angles, label them and compare. For naming the angles, you have to write points on them. For example, you can write A, B, C here. You can write here angle K, L, M here. You can write here E, F, G here. You can write here X, Y, Z. So the angle will become in first picture angle ABC, in second one angle KLM, in third picture angle EFG, and in fourth one angle XYG. Can you identify which is the largest and which is the smallest? If you guess this is the smallest one, and if you see it properly, then this is the largest one. So if you compare these two, then you can see this is larger than this. This is the smallest, this is the largest, this is larger, and this is smaller. So if you arrange them in ascending order, then angle EFG is smallest, larger than that is angle XYZ, larger than that is angle KLM, and largest is angle ABC. This is symbol for greater than. Okay. Comparing angles by superimposition. Any two angles can be compared by placing them one over the other, that is, by superimposition. While superimposing, the vertices of the angles must overlap. After superimposition, it becomes clear which angle is smaller and which is larger. For example, if you superimpose the angle ABC, that is this one, over this one, that is angle PQR, you will get this picture. From this picture, you can observe that angle PQR is greater than or larger than angle ABC. The picture shows the two angles superimposed. It is now clear that angle PQR is larger than angle ABC. Equal angles. Now consider angle AOB and angle XOY in the figure. Which is greater? If you superimpose the angle AOB over angle XOY, you will get this picture. This signifies that both are equal. The corner of both of these angles match and the arms overlap with each other. That is, AO overlaps OX and OB overlaps OY. So, the angles are equal in size. The reason these angles are considered to be equal in size is because when we visualize each of these angles as being formed out of rotation, we can see that there is an equal amount of rotation needed to move ray OB to ray OA and ray OY to ray OX. From the point of view of superimposition, when two angles are superimposed and the common vertex and the two rays of both angles lie on top of each other, then the sizes of the angles are equal. Where else do we use superimposition to compare? While using torans for decoration, we place each piece of paper over other to see whether they are equal or not. Figure it out. 1. Hold a rectangular sheet of paper, then draw a line along the fold created. Name and compare the angles formed between the fold and the sides of the paper. Make different angles by folding a rectangular sheet of paper and compare the angles. Which is the largest and smallest angle you made? For this paper, you have to name the corners. Then the crease created or the fold created. The angle AXY is larger than angle BXY. Okay, you can compare like that. 2. In each case, determine which angle is greater and why. A. Angle AOB or angle XOY. AOB means this one. Angle XOY means this one. From figure, you can see that angle AOB is greater. Similarly, B. Angle AOB or angle XOB. AOB and XOB. In this also, angle AOB is greater. C. Angle XOB or angle XOC. XOB and XOC are equal. Both are equal. Discuss with your friends on how you decided which one is greater. 3. Which angle is greater, angle XOY or angle AOB? Give reasons. XOY, that is this one. AOB, that is this one. From figure, it is very difficult to tell which one is greater, that is XOY or AOB. Okay, both looks equal. Okay, you have to use a different method for doing that. Comparing angles without superimposition. Two cranes are arguing about who can open their mouth wider, that is, who is making a bigger angle. Let us first draw their angles. How do we know which one is bigger? As seen before, one could trace these angles, superimpose them and check. But can we do it without superimposition? Suppose we have a transparent circle which can be moved and placed on figures. Can we use this for comparison? Let us place the circular paper on the angle made by the first crane. The circle is placed in such a way that its center is on the vertex of the angle. Let us mark the points A and B on the edge circle at the points where the arms of the angle pass through the circle. If you want to measure angle AOB, then you have to place the vertex of the angle to the center of the circle like this. And after placing like that, you have to mark the point A and B on the circle like this. Can we use this to find out if this angle is greater than or equal to or smaller than the angle made by the second crane? Let us place it on the angle made by the second crane so that the vertex coincides with the center of the circle and one of the arms passes through AO. Like this. Can you now tell which angle is bigger? If you have noticed the two cranes, that is, they are making angle AOB and XOY. Then, after placing that on the circle, you will observe that angle XOY is smaller than angle AOB. That means the first crane that is making an angle AOB has larger mouth opened. Kindly observe the figure given here carefully. You can see angle AOB and angle XOY. You can observe that angle AOB is larger than angle XOY. Which crane was making the bigger angle? If you can make a circular piece of transparent paper, try this method to compare the angles in figure 2.10 with each other. Teacher's note. A teacher needs to check the understanding of the students around the notion of an angle. Sometimes a student might think that increasing the length of the arms of the angle increases the angle. For this, various situations should be posed to the students to check their understanding on the same. 2.7 Making rotating arms. Let us make rotating arms using two paper straws and a paper clip by following these steps. 1. Take two paper straws and a paper clip. 2. Insert the straw into the arms of the paper clip. 3. Your rotating arm is ready. First, you have to take paper clip like this and paper straws like this. You have to insert paper straws into paper clips like this. After inserting, you will get a flexible rotating arm like this. Make several rotating arms with different angles between the arms. Arrange the angles you have made from smallest to largest by comparing and using superimposition. Passing through a slit. Collect a number of rotating arms with different angles. Do not rotate any of the rotating arms during this activity. Take a cardboard and make an angle-shaped slit as shown below by tracing and cutting out the shape of one of the rotating arms, like this. Now, shuffle and mix up all the rotating arms. Can you identify which of the rotating arms will pass through the slit? The correct one can be found by placing each of the rotating arms over the slit. Let us do this for some of the rotating arms. Slit angle is greater than the arm's angle. The arms will not go through the slit. For this picture, for this one, slit angle is less than the arm's angle. The arms will not go through the slit. For this picture, slit angle is equal to the arm's angle. The arms will go through the slit. Only the pair of rotating arms where the angle is equal to that of the slit passes through the slit. Note that the possibility of passing through the slit depends only on the angle between the rotating arms and not their lengths, as long as they are shorter than that of the length of the slit. Challenge: reduce this angle. This girl, snip, angle reduced. The angle is still the same. For example, for this angle, if you reduce the arm's length, but the angle will remain the same. Two point eight Special types of angles. Let us go back to Vidya's notebook and observe her opening the cover of the book in different scenarios. We have already seen different scenarios, such as this one, this one, this one, this one, this one, and this one. She makes a full turn of the cover when she has to write while holding the book in her hand, like this. She makes a half turn of the cover when she has to open it on her table, like this. In this case, observe the arms of the angle formed. They lie in a straight line. Such an angle is called a straight angle. That is this one. It's look like this. The angle is named angle AOB. Here angle AOB is a straight angle. Let us consider a straight angle, angle AOB. Observe that any ray OC divides it into two angles, that is angle AOC and angle COB. That is, a ray OC divides angle AOB into two angles, that is angle AOC and BOC or COB. Okay, AOC and COB written here. You can see AOC and COB. That is two parts of straight angle AOB. Is it possible to draw a ray OC such that the two angles are equal to each other in size? Yes, you can draw like this such that this angle is equal to this angle. That is AOC is equal to COB. Let's explore. We can try to solve this problem using a piece of paper. Recall that when a fold is made, it creates a crease which is straight. Take a rectangular piece of paper and on one of its sides, mark the straight angle AOB. By folding, try to get a line crease passing through O that divides angle AOB into two equal angles. How can it be done? It can be done like this. Okay, follow these steps. Fold the paper such that OB overlaps with OA. Observe the crease and the two angles formed. Okay, in this figure, you can see you have to fold in such that OB overlaps OA like this. Then you have to unfold and see the angle formed between AOC, this point is C, and COB. Both will be equal. Justify why the two angles are equal. Is there a way to superimpose and check? Can this superimposition be done by folding? Each of these equal angles formed are called right angles. So, a straight angle contains two right angles. That is, angle AOC is right angle and angle COB is right angle. Right angle are equal to each other. So you can say a straight angle contains two right angles. You can see it here. You can see a picture is given here. This set square asks this set square that why shouldn't you argue with a 90-degree angle? This set square replies because they are always right. Okay, 90-degree means right. And in reply, he says they are always right. So you shouldn't argue with 90-degree angle or right angle because they are always right. If a straight angle is formed by half of a full turn, how much of a full turn will form a right angle? If you could remember, a full turn that is double of straight angle, that is straight angle this side and straight angle this side. That means if you split a straight angle into two right angles, that means you will get 1, 2, 3, 4. 4 right angles in a full turn or complete angle. Observe that a right angle resembles the shape of an L. An angle is a right angle only if it is exactly half of a straight angle. Two lines that meet at right angles are called perpendicular lines. For example, these two. They are called perpendicular lines because they are making right angle with each other. Figure it out. 1. How many right angles do the windows of your classroom contain? Do you see other right angles in your classroom? 2. Join A to other grid points in the figure by a straight line to get a straight angle. What are all the different ways of doing it? You can join these points such that a straight angle is formed like this. Similarly, you can do it here. 3. Now join A to other grid points in the figure by a straight line to get a right angle. What are all the different ways of doing it? For simplicity, you can make a straight angle like this and divide this into two halves. Okay, like this you will get 1, 2, 3, 4, 4 right angles at A. Similarly, you can join these points and make 1, 2, 3 and 4 right angles at A. Hint: extend the line further as shown in the figure below. To get a right angle at A, we need to draw a line through it that divides the straight angle CAB into two equal parts, like this, such that right angles are formed at A. 4. Get a slanting crease on the paper. Now try to get another crease that is perpendicular to the slanting crease. A. How many right angles do you have now? Justify why the angles are exactly right angles. B. Describe how you folded the paper so that any other person who doesn't know the process can simply follow your description to get the right angle. Classifying angles. Angles are classified in three groups as shown below. This one, and this one. Right angles are shown in the second group, that is this one. What could be the common feature of the other two groups? If you observe these angles properly, you can observe angles as arms and vertices. They are common to all. And in the first group, you can see the angles are less than right angle. And in the second group, angles are more than right angle. Okay, all are less than 90 degree, all are greater than 90 degree. In the first group, all angles are less than right angle, or in other words, less than a quarter turn. Such angles are called acute angles. Okay, these are acute angles. In the third group, all angles are greater than a right angle but less than a straight angle. The turning is more than a quarter turn and less than a half turn. Such angles are called obtuse angles. These angles are called obtuse angles. Figure it out. 1. Identify acute, right, obtuse and straight angle in the previous figures. 2. Make a few acute angles and a few obtuse angles. Draw them in different orientations. 3. Do you know what the words acute and obtuse mean? Acute means sharp and obtuse means blunt. Why do you think these words have been chosen. 4. Find out the number of acute angles in each of the figures below. 1, 2, 3. 3 acute angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 acute angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That is 21 acute angles. What will be the next figure and how many acute angles will it have? Do you notice any pattern in the numbers? If you see here, after 3, 12, and after 12, there is 21. Okay, if 9 is added to 3, you will get 12. If 9 is added to 12, you will get 21. And in the next pattern, there will be 30 acute angles. That is 21 plus 9. 2.9 Measuring angles. We have seen how to compare two angles. But can we actually quantify how big an angle is using a number without having to compare it to another angle? We saw how various angles can be compared using a circle. Perhaps a circle could be used to assign measures for angles. You can see a circle denoting complete angle, but in the next picture it has been splitted in various angles. Kindly observe here written 0 degree, here 10. That is, from here to here the angle is 10 degree. Similarly, from here to here the angle is 20. Here to here 30. Similarly, here to here, that is 90 degree. Similarly, a straight angle like this. Similarly, a straight angle like this. Similarly, a straight angle like this. That is 180 degree. Right angle means 90 degree. A straight angle means 180 degree. Angle less than 90 degree are called acute angles. That means 0, 10, 20, 30, 40, 50, 60, 70, 80 are acute angles. Angle greater than right angle but less than straight angle are called obtuse angle. That is 100, 110, 120, 130, 140, 150, 160, 170. And the smaller angles within it, that is 91, 92, 93, like that up to 100, 101, 102, 103, up to 110 here. Similarly, many angles are there within. Similarly, this is also true for acute angles. There could be angles like 43, 45, 47 or 67, 68, 69. All these are acute angles. Similarly, angles greater than 180, that is straight angle, is represented here. The last angle is 360, that is complete angle, and it is equal to 0 degree. Okay, kindly try to understand this. To assign precise measures to angles, mathematicians came up with an idea. They divided the angle in the center of the circle into 360 equal angles or parts. The angle measure of each of these unit parts is 1 degree, which is written as 1 degree. This unit part is used to assign measure to any angle. The measure of an angle is the number of 1 degree unit parts it contains inside it. For example, see this figure. It contains 30 units of 1 degree angle, and so we say that its angle measure is 30 degree. Measures of different angles. What is the measure of a full turn in degrees? As we have taken it to contain 360 degrees, its measure is 360 degree. What is the measure of a straight angle in degrees? A straight angle is half of a full turn. As a full turn is 360 degree, a half turn is 180 degree. What is the measure of a right angle in degrees? Two right angles together form a straight angle. As a straight angle measures 180 degree, a right angle measures 90 degree. You can see this is a straight angle, so this is 180 degree. This is right angle, so this is 90 degree. A pinch of history. A full turn has been divided into 360 degree. Why 360? The reason why we use 360 today is not fully known. The division of a circle into 360 parts goes back to ancient times. The Rig Veda, one of the very oldest texts of humanity, going back thousands of years, speak of a wheel with 360 spokes, verse 1.164.48. Many ancient calendars, also going back over 3000 years, such as calendars of India, Persia, Babylonia, and Egypt, were based on having 360 days in a year. In addition, Babylonian mathematicians frequently used division of 60 and 360 due to their use of sexagesimal numbers and counting by 60s. Perhaps the most important and practical answer for why mathematicians over the years have liked and continued to use 360 degrees is that 360 is the smallest number that can be evenly divided by all numbers up to 10, aside from 7. Thus, one can break up the circle into 1, 2, 3, 4, 5, 6, 8, 9 or 10 equal parts and still have a whole number of degrees in each part. Note that 360 is also evenly divisible by 12, the number of months in a year, and by 24, the number of hours in a day. These facts all make the number 360 very useful. The circle has been divided into 1, 2, 3, 4, 5, 6, 8, 9, 10 and 12 parts below. What are the degree measures of the resulting angles? Write the degree measures down near the indicated angles. This is 360. This is 180 degree. In third figure, we have to divide 360 by 3. it will be 120 degree. Similarly, 4 parts, that is 90 each. 90 degree. 5 parts, that means you have to divide 360 by 5. You will get 72 degree. Similarly, 6 parts means you have to divide by 6. You will get 60. Similarly, 8 part, that means you have to divide by 8. You will get 45 degree. Similarly, 9 parts, that means you have to divide by 9. You will get 40 degree. 10 parts, that means 36 degree, that is 360 divided by 10, 36 degree. And by 12, that is 12 here, 360 here. 30 degree. Degree measures of different angles. How can we measure other angles in degrees? It is for this purpose that we have a tool called a protractor, that is either a circle divided into 360 equal parts as shown in figure 2.12 on page 32, or a half circle divided into 180 equal parts. Unlabeled protractor. Here is a protractor. Do you see the straight angle at the center divided into 180 units of 1 degree? Only part of the lines dividing the straight angles are visible though. You can see an unleveled protractor here. By your previous experiences, you can mark the angles on it. For example, this is 90 degree, that means here you have to write 90 degree. How many parts? That is 1, 2, 3, 4, 5, 6, 7, 8, 9. That means you have to write 10 degree here, 20 degree here, 30 here, 40 here, 50 here, 60 here, 70 here, and 80 here. Okay. Similarly, you can measure angles greater than 90 but less than 180 degree. Starting from the marking on the rightmost point of the base, there is a long mark for every 10 degree. From every such long mark, there is a medium sized mark after 5 degree. You can see this one medium size, that means 5 degree. This one medium size mark, that means 15 degree. Here 25 degree. Here 35 degree. Here 35 degree, here 45 degree, and so on. And very small marks are there, that signifies 1 degree. There are 5 ones between 0 and 5, that means 1 degree, 2 degree, 3 degree, 4 degree, and 5 degree. 6, 7, 8, 9, that is counting numbers. Figure it out. 1. Write the measures of the following angles. A. Angle KAL. K, A, and L. That means 10 degree, 20 degree, and here 30 degree, or 1 10, 2 tenths, 3 tenths. That is from here to here 30 degree. Notice that the vertex of this angle coincides with the center of the protector. So the number of units of 1 degree angle between KA and AL gives the measure of angle KAL. By counting, we get angle KAL is equal to 30 degree. You can count in numbers, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, if you count in 1, you will get 30. That means 30 degree. Making use of the medium-sized and large-sized marks, is it possible to count the number of units in 5s or 10? Yes, you can skip in 5 and count the number. Or you can skip in 10. You can count in tens and reach 30 by jumping 3 times. That means 10 into 3 is 30 degree. B. Angle WAL. You have to measure angle WAL. That is W, then A and L. You can skip in 5 or 10 as you wish. Here 10, 20, 30 and 40 and 50. That means this is equal to 50 degree. Angle WAL is 50 degree. Similarly, see angle TAK, that is T, A and K, the bigger one, this one. Count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 into 10, that is 120. That means 120 degree. Labeled protector. This is a protector that you find in your geometry box. It would appear similar to the protector above, except that there are numbers written on it. Will this make it easier to read the angles? Yes, it will become easy to read the angles here. You can see it. There are two sets of numbers on the protector, one increasing from right to left and the other increasing from left to right. Why does it include two sets of numbers? If you see it properly, you can see a number in increasing order, that is 0, 10, 20, like this. Similarly, you can see numbers in decreasing order, that is 180, 170, 160, like that. You can see that here too. Name the different angles in the figure and write their measures. You have to see different angles in this figure and write the measures. Angle POQ. If you count 0, 10, 20, 30 and 5, that is 35 degree. Angle POR. Angle POR, that is up to here. You can see 90 here, after that 5. That is angle POR is 95 degree. Similarly, POS, that is greater than 120 degree. 120 degrees here and 5 more than that. That is angle POS is equal to 125. Similarly, angle POT, it is at 160 degree. Similarly, POU, that is 180 degree, that is a straight angle. Similarly, there are other angles hidden here. For example, angle QOR. QOR can be written as angle POR minus angle POQ. That is 95 minus 35. You will get 60 degree. You can count in tens. 10, 20, 30, 40, 50 and 60 here. That is angle QOR is 60 degree. Similarly, you can measure angle QOS. You can measure angle ROS. You can measure QOT. You can measure ROT. Like that, there are many angles hidden here. Did you include angles such as angle TOQ? Which set of markings did you use, inner or outer? What is the measure of angle TOS? Can you use the numbers marked to find the angle without counting the number of markings? Here, OT and OS pass through the numbers 20 and 55 on the outer scale. How many units of 1 degree are contained between these two arms? Can subtraction be used here? If you have to measure angle TOS, that is TOS, you can see the angle from here to here is 55 and from here to here is 20. So the gap is 55 minus 20, that is equal to 35 degree. So measure of angle TOS is 35 degree. You can count in tens and fives. 10, 20 and 30 and 5 more. That is 35 from here to here. 35. A better way is to subtract 20 from 55 like this. How can we measure angles directly without having to subtract? Place the protractor so the center is on the vertex of the angle, like this. Align the protractor so that one of the arms passes through the 0 degree mark as in the picture below. You can see one arm is passing through 0 degree line. What is the degree measure of angle AOB? That is 80 degree. Angle AOB is equal to 80 degree. Make your own protractor. You may have wondered how the different equally spaced markings are made on a protractor. We will now see how we can make some of them. 1. Draw a circle of a convenient radius on a sheet of paper. Cut out the circle. Figure 2.13. A circle or one full turn is 360 degree. 2. Fold the circle to get two equal halves and cut it through the crease to get a semicircle. Write 0 degree in the bottom right corner of the semicircle, like this. The measure of half a circle is half of a full turn, figure 2.14, that is this one. So the measure of half a turn is half of 360, that is equal to 180 degree. Thus, write 180 in the left bottom corner of the semicircle. 3. Fold the semicircular sheet in half as shown in figure 2.15 to form a quarter circle. The measure of a quarter circle is 1 by 4 of a full turn. The measure of a 1 by 4 turn is equal to 1 by 4 of 360, that is equal to 90 degree. Or the measure of a 1 by 4 turn or half of a half turn is half of 180 degree is equal to 90 degree. Thus, mark 90 degree at the top of the semicircle, like this. 4. Fold the sheet again as shown in figures 2.16 and 2.17, like this. You will get angles 45 and 135. When folded, this is 1 by 8 of the circle or 1 by 8 of a turn or 1 by 8 of 360 or 1 by 4 of 180 degree or half of 90 degree, that is equal to 45 degree. The new creases formed gave us measures of 45 and 180 minus 45, that is 135 degree as shown. Write 45 and 135 degree at the correct places on the new creases along the edge of the semicircle. 5. Continuing with another half fold as shown in figure 2.18, we get an angle of measure half of 45 degree, that is 22 and half, or you can write 22.5 degree, that is 22.5 degree. 6. Unfold and mark the creases as OB, OC, dash dash dash, etc. as shown in figure 2.19 and figure 2.20, like this. The new angles are 22.5, 67.5, 112.5, 157.5. Think. In figure 2.20, we have angle AOB is equal to angle POC, angle COD is equal to angle DOE is equal to angle EOF is equal to angle FOG is equal to GOH is equal to HOI, that is equal to 22.5 degree. Why? You can see this picture. All angles are equal to 22.5 degree, that is 1 by 8 of 180 degree, or 1 by 4 of 90 degree, or 1 by 2, that is half of 45 degree. Angle bisector. At each step, we fold it in halves. This process of getting half of a given angle is called bisecting the angle. The line that bisects a given angle is called the angle bisector of the angle. Identify the angle bisector in your handmade protractor. Try to make different angles using the concept of angle bisector through paper folding. In first picture, this one is the angle bisector, that is, it bisects 360 into 180 and 180. Similarly, this line is an angle bisector, divides 180 into two right angles, that is 90 degree and 90 degree each. Similarly, this is an angle bisector. It divides the angle here, that is right angle or 90 degree, into 45 degree and 45 degree. Similarly, half of 45, that is 22.5 and 22.5 here. So this line is the angle bisector, that is it bisects this angle 45. Similarly, you can see many angle bisectors here. Figure it out. 1. Find the degree measures of the following angles using your protractor. You have to use your protractor to find the measure of angles I, H, J in all the three pictures. 2. Find the degree measures of different angles in your classroom using your protractor. Teacher's note. It is important that students make their own protractor and use it to measure different angles before using the standard protractor so that they know the concept behind the marking of the standard protractor. 3. Find the degree measures of the angles given below. Check if your paper protractor can be used here. 4. How can you find the degree measure of the angles given below using a protractor? You already know that you can measure angles that are less than 180 degree using a semicircular protractor. But this angle seems to be greater than 180 degree. So what you can do is, you could first measure this angle. Suppose this angle is x. Then you have to subtract this value so that you will get this value, that is y. You have to find y, but using a protractor you can find x. For example, if this angle is 120 degree, then 360 minus 120 will give you y, that is this angle y. So the answer will be 240 degree. So this angle will be 240 degree. I have done this without measuring this angle. I have taken this angle as 120 degree, but this is not so. Kindly measure this and then subtract this from 360, you will get this angle. 5. Measure and write the degree measures for each of the following angles, A and B. You can use your protractor to find this out. Similarly, you can do for C, D, E and F. 6. Find the degree measures of angle BXE, angle CXE, angle AXB and angle BXC. 115 degree, 85 degree, here 180 minus 115 or 65 degree, and the last one 115 degree minus 85 degree, that is equal to 30 degree. If you see the picture carefully, this angle is equal to this angle minus this angle. Similarly, this angle is equal to 180 degree minus this angle. 7. Find the degree measures of angle PQR, angle PQS and angle PQT. You can use your protractor to find this out. 8. Make the paper craft as per the given instruction. Then unfold and open the paper fully. Draw lines on the creases made and measure the angles formed. You have to follow the pictorial instructions given here. 9. Measure all three angles of the triangle shown in figure 2.21a and write the measures down near the respective angles. Now add up the three measures. What do you get? Do the same for the triangles in figure 2.21b and c. Try it for other triangles as well. And then make a conjecture for what happens in general. We will come back to why this happens in a later year. If you measure angle A, angle B and angle C and add them up, you will get 180 degree. Similarly, for this picture, if you measure angle A, angle B and angle C and add them up, you will get 180 degree again. And for this triangle too, you will get 180 degree again. This is true for any triangle. The sum of all the angles, that is sum of all the corner angles, is equal to 180 degree or a straight angle. Mind the mistake, mend the mistake. A student used a protractor to measure the angles as shown below. In each figure, identify the incorrect uses of the protractor and discuss how the reading could have been made and think how it can be corrected. In the first picture, it is written angle U is equal to 35 degree. First, you have to align this 0 degree mark to one of the arm of the angle. So, it's wrong measurement. In the second one, the same problem, you have to align this 0 degree mark with any of the arm of the angle. So, you have to align this arm with 0 degree mark. So, this is wrong. Similarly, the problem here, but if you see this one, though this is aligned, but you can see the vertex doesn't match with the vertex or center of the protector. So this is wrong and this is wrong. Similarly, you can see this vertex is not overlapping the center of the protector. So this is wrong. But in the last one, you can see this is correctly placed. But the mistake is that you have to write 105 degree instead of 85 degree because you are measuring from 0 to 105 from this side. So the answer is 105 degree. Figure it out. Where are the angles? 1. Angles in a clock. A. The hands of a clock make different angles at different times. At 1 o'clock, the angle between the hands is 30 degree. Why? You can see a clock here. In a clock, the whole circle is divided into 12 parts. That means 360 divided by 12 will give you 30 degree. That means That means all the 12 parts, that is 1 to 2, 2 to 3, 3 to 4 are making 30 degree at the center. This one 30 degree, this one 30 degree, similar to our protector. So at 1 o'clock, the angle between hands will be 30 degree. B. What will be the angle at 2 o'clock and at 4 o'clock, 6 o'clock? At 2 o'clock, there will be 60 degree. At 4 o'clock, 30, 30, 60, 30, 90, 30, 120. The angle will be 120 degree. At 6 o'clock, the hands will be straight. So there will be a straight angle. So at 6 o'clock, there will be 180 degree. C. Explore other angles made by the hands of a clock. 2. The angle of a door. Is it possible to express the amount by which a door is opened using an angle? What will be the vertex of the angle and what will be the arms of the angle? You can see here an angle is being formed. You can see this wall is acting as an arm. This door is acting as an arm. The angle formed here is this one. 3. Vidya is enjoying her time on the swing. She notices that the greater the angle with which she starts the swinging, the greater is the speed she achieves on her swing. But where is the angle? Are you able to see any angle? She says greater is the speed when she starts with greater angle. That means if she starts from here, then the speed will be greater. So the angle is measured from this arm. Okay, that is the branch of the tree. And the other arm is the rope through which she is hanging. So the angle is made here. 4. Here is a toy with slanting slabs attached to its sides. The greater the angles or slopes of the slabs, the faster the balls roll. Can angles be used to describe the slopes of the slabs? What are the arms of each angle? Which arm is visible and which is not? In the given figure, you can see an arm of the angle on which ball is rolling. The other arm, that is the invisible one, is horizontal. Greater the angle between the arms, greater is the speed of the rolling balls. 5. Observe the images below where there is an insect and its rotated version. Can angles be used to describe the amount of rotation? How? What will be the arm of the angle and the vertex? And observe the horizontal line touching the insects. You can see in the first picture there is rotation about this axis. The angle formed is 90 degree. In the second picture, there is rotation about this axis. The angle formed is 90 degree or right angle. Teachers note, it is important that students see the application of each mathematical concept in their daily lives. Teacher can organize some activities where students can appreciate the practical applications of angles in real life situations. Example: clocks, doors, swings, concepts of uphill and downhill, location of the sun, the giving of directions, etc. 2.10 Drawing angles. Vidya wants to draw a 30-degree angle and name it angle TIN using a protractor. In TIN, I will be the vertex, IT and IN will be the arms of the angle. Keeping one arm, say IN, as the reference, that is base, the other arm, IT, should take a turn of 30 degree. Step 1. We begin with the base and draw ray IN like this. Step 2. We will place the center point of the protractor on I and align IN to the zero line like this. Step 3. Now starting from 0, count your degrees 0, 10, 30 up to 30 on the protractor. Mark point T at the level 30 degree like this. Step 4. Using a ruler, join the point I and T. Angle TIN is equal to 30 degree is the required angle. Like this. You have to join point I to point T. The angle formed is angle 30 degree, that is angle TIN, that is equal to 30 degree. Let's play a game. #1. This is an angle guessing game. Play this game with your classmates by making two teams, Team 1 and Team 2. Here is the instructions and rules for the game. Team 1 secretly choose an angle, measure, for example, 49, and makes an angle with that measure using a protractor without Team 2 being able to see it. Team 2 now gets to look at the angle. They have to quickly discuss and guess the number of degrees in the angle without using a protractor. Team 1 now demonstrates the true measure of the angle with a protractor. Team 2 scores the number of points, that is the absolute difference in degrees between their guess and the correct measure. For example, if Team 2 guesses 39, then they score 10 points, that is 49 minus 39. Each team gets 5 turns. The winner is the team with the lowest score. Let's play a game has to. We now change the rules of the game a bit. Play this game with your classmates by again making two teams, Team 1 and Team 2. Here are the instructions and rules. Team 1 announces to all an angle measure, example 34 degree. A player from Team 2 must draw that angle on the board without using a protractor. Other members of Team 2 can help the player by speaking words like make it bigger or make it smaller. A player from Team 1 measures the angle with a protractor for all to see. Team 2 scores the number of points, that is the absolute difference in degrees between Team 2's angle size and the intended angle size. For example, if player's angle from Team 2 is measured to be 25 degree, then Team 2 scores 9 points, that is 34 degree minus 25 degree. Each team gets 5 turns. The winner is again the team with the lowest score. Teacher's note: these games are important to play to build intuition about angles and their measures. Return to this game at least once or twice on different days to build practice in estimating angles. Note that these games can also be played between pairs of students. Figure it out. 1. In figure 2.23, list all the angles possible. Did you find them all? Now, guess the measures of all the angles. Then, measure the angles with a protractor. Record all your numbers in a table. See how close your guesses are to the actual measures. 2. Use a protractor to draw angles having the following degree measures: A 110 degree, B 40 degree, C 75 degree, D 112 degree, E 134 degree. 3. Draw an angle whose degree measure is the same as the angle given below. First, you have to measure this angle and then you have to draw this angle using protractor. Also, write down the steps you followed to draw the angle. 2.11 Types of angles and their measures. We have read about different types of angles in this chapter. We have seen that a straight angle is 180 degree and a right angle is 90 degree. How can other types of angles, acute and obtuse, be described in terms of their degree measures? Acute angle. Angles that are smaller than the right angle, that is less than 90 degree and greater than 0 degree, are called acute angles. For example, 40 degree, 50 degree, 75 degree. Examples of acute angles. Obtuse angle. Angles that are greater than the right angle and less than the straight angle, that is greater than 90 degree and less than 180 degree, are called obtuse angles. For example, 110 degree, 130 degree. Examples of obtuse angles. Have we covered all the possible measures that an angle can take? Here is another type of angle. Reflex angle. Angles that are greater than the straight angle and less than the whole angle, that is greater than 180 degree and less than 360 degree, are called reflex angles. For example, this angle and this angle are greater than 180 degree but less than 360 degree. So these are reflex angles. Examples of reflex angles. Figure it out. 1. In each of the below grids, join A to other grid points in the figure by a straight line to get A, an acute angle. Like this. Like this. B, an obtuse angle. That is like this. This is right angle. So you have to draw angle greater than that. Like this. C, reflex angle. Like this. Mark the intended angles with curves to specify the angles. One has been done for you. Let's explore. In this figure, angle TER is equal to 80 degree. That is this one. What is the measure of angle BET? It is asked what is the measure of this angle. So you can write that this is 180 degree minus 80 degree. That is 100 degree. So angle BET is equal to 100 degree. What is the measure of angle SET? In figure you can see angle SER is equal to 90 degree. So angle SET is equal to 90 degree minus 80 degree. That is angle SER minus angle TER. So angle SET is equal to 90 degree minus 80 degree. That is 10 degree. Hint, observe that angle REB is a straight angle. Hence, the degree measure of angle REB is equal to 180 degree, of which 80 is covered by angle TER. A similar argument can be applied to find the measure of angle SET. Figure it out. 1. Draw angles with the following degree measures. A. 140 degree. B. 82 degree. C. 195 degree. D. 75 degree. E. 35 degree. 2. Estimate the size of each angle and then measure it with a protractor. A. This one, and this one, and so on. Classify these angles as acute, right, obtuse, or reflex angles. 3. Make any figure with 3 acute angles, 1 right angle, and 2 obtuse angles. 4. Draw the letter M such that the angles on the sides are 40 degree each and the angle in the middle is 60 degree. 5. Draw the letter Y such that the 3 angles formed are 150 degree, 60 degree and 150 degree. 6. The Ashok Chakra has 24 spokes. What is the degree measure of the angle between two spokes next to each other? What is the largest acute angle formed between two spokes? For this question, you can divide 360 by 24. 15 times. That means there is 15 degree between two spokes. 7. Puzzle. I am an acute angle. If you double my measure, you get an acute angle. If you triple my measure, you will get an acute angle again. If you quadruple 4 times my measure, you will get an acute angle yet again. But if you multiply my measure by 5, you will get an obtuse angle measure. What are the possibilities for my measure? Summary. A point determines a location. It is denoted by a capital letter. A line segment corresponds to the shortest distance between two points. The line segment joining points S and T is denoted by ST bar. A line is obtained when a line segment like ST is extended on both sides indefinitely. It is denoted by ST double-headed arrow or sometimes by a single small letter like M. A ray is a portion of a line starting at a point D and going in one direction indefinitely. It is denoted by dP with single-headed arrow, where P is another point on the ray. An angle can be visualized as two rays starting from a common starting point. Two rays OP and OM form the angle POM, also called angle MOP. Here O is called the vertex of the angle and the rays OP and OM are called the arms of the angle. The size of an angle is the amount of rotation or turn needed about the vertex to rotate one ray of the angle onto the other ray of the angle. The sizes of angles can be measured in degrees. One full rotation or turn is considered as 360 degrees and denoted as 360 degree. Degree measures of angles can be measured using a protractor. Angle can be straight 180 degree, right 90 degree, acute more than 0 degree and less than 90 degree, obtuse more than 90 degree and less than 180 degree, and reflex more than 180 degree and less than 360 degree. For more videos, you can subscribe NCERT video. Thank you.